All right, so next section is looking at how to graph functions. And I know you've been graphing functions in college algebra, but most of the times we use the calculator to graph functions. But since in pre-calc we have to stop using the calculators, we're going to concentrate more on how to do things by hand. And this is going to come into place when you take calculus. You will have a better understanding of what's going on if you graph everything by hand. So, graphing is the most important way to visualize a function. And basically, the graph of a function is just going to be plotting a bunch of points x, y in the coordinate plane. So you pick an x in the domain and plot it with its corresponding y. So for example, if you have a linear function, we know that a linear function is of the form mx plus b, where m is the slope and b is the y-intercept. So if I have a function f of x equals 2/3 x plus 1, how do I graph this? I'm not going to pull out my calculator and do it. I'm going to think that b is 1 and b is the y-intercept. So it crosses the y-axis at 1. And then I'm going to think that the slope is 2/3. So remember, the slope means change in y over change in x. So this is positive. So that means change in y and change in x is positive. So if I go up 2 units, so 2 changes in y, so 1, 2, and to the right 3 units for change in x, 1, 2, 3, that's going to give me my next point. And I have 2 points, so I can connect them, and I graphed the line without using a calculator. Okay? Now, for example, so this is an example with the slope being positive, slope positive. The function f is increasing. What about if I have f of x equals -1/2 x minus 2? Again, I'm not going to pull out my calculator. I'm going to think the y-intercept is -2, so it's going to cross the y-axis here. When x is 0, y is 2. And then the slope is -1/2. So if I start here, and if I go, since it's negative, if I go down 1 unit and 2 to the right, I get my next point. Or I can also think that I can go up 1 y, but to the left 2 x's. So that's going to give me another point. Okay, so -1/2, I can either distribute the negative to the y by going down 1 unit, and then the 2 will stay positive, so I go to the right 2 unit for x, or I can distribute the negative to the 2, so it's 1 up and 2 to the left. Either way, the points are going to be on the same line, so when I graph, I connect the points, I get the same. What about when I have f of x equals 3? Is this a linear function? Yes, it is. And what is its slope? Well, the slope is not there, so the slope is 0. So I can think that I can rewrite this as f of x equals 0 times x plus 3. So the slope is 0, so that means there is no change in y. So what is the y-intercept in here? Well, it's 3. mx plus b, so the y-intercept is 3. So if I start here, there is no change in y. So no matter how much I change x, the y is going to stay the same. So no change in y. If I change x by 1, the y is going to stay here. If I change x by 2, the y is going to stay here. So similarly, so this is just a horizontal line, y equals 3. And this is a constant linear function. Okay, so these are stuff that you have seen before. All power functions, for example. If you recall, power functions are of the form y equals k times x to the p. Or you can think about it, f of x equals k times x to the p. So first we're going to look when p is a positive exponent. And again, we can't use our calculator, so we need to think how we're gonna, so for example, let's say that f of x is 2x to the 4, and let's look at another one, f of x equals 3x cubed. So this is an example of power function. What's the difference between these two? The exponents are both positive, but this exponent is even, and this exponent is odd. So the graphs are going to look different depending on if the positive exponent is an even number or an odd number. So let's see how we're going to graph this. F of x equals 2x to the 4. What is the domain of this function? Domain is all real numbers. So I can pick anything. So let's say if x is -1, so if x is -1, the y will be 2 times -1 to the 4th. The y is 2. So when x is -1, the y is 2. When x is 0, 2 times 0 to the 4th is 0. So we'll go here. When x is +1, 2 times 1 to the 4th is 2. +1 is 2. If I put x is 2, I'll have 2 times 2 to the 4th. 2 to the 4th is 16. And then 2 times 16 is 32, so it'll be way off my graph. So I'm going to be okay with graphing just this. So if you recall, 2x to the 4th is going to look similar to the parabola 2x squared, but it's just flatter at the vertex. So I can connect these and just draw it flatter in here. So this is how all of the power functions with positive even exponent are going to look. So x to the 6 is still going to be like this, just flatter, even more flatter. X to the 100 is still going to have this general shape, just flatter at the origin, at the vertex. All right, what about when p is even now? Well, still, we're going to, the domain for this one as well is -infinity to infinity. We're going to pick some x's. So when x is -1, I'll have 3 times -1 cubed. So when x is -1, 3 times -1 cubed is -3. -1 for x, -3 for 1. -3. When x is 0, I'll have 0. When x is 1, I'll have 3. And then if you notice now, I'm not quite sure how to connect these points. Like I can connect them as a line, but I know that this is not a line because it has degree 3. So if I think at, let's see, at 2, when x is 2, I'll have that y is 3 times 2 to the 3rd is 3 times 8, which is 24. So when x is 2, y will be 24, and it's right here, so it's not going to stay in line. So if you remember, this kind of looks like an S shape, like that. Again, if this exponent is 5 or 7 or 11, this is just going to be flatter at this origin right here. Okay, so that was power functions with positive exponents. Now let's look at power functions with negative exponents. And this, again, power function is of the form k times x to the p. Oh, one more question. what happens if this k is negative? Do you remember that from algebra? If k is negative, so for example, I wanted to do negative 2x to the fourth, what happens is the graph flips over the x-axis. So I can just draw this one here. So if this is negative 2x to the fourth, so the graph flips if k becomes negative. And for this one, it will flip this way over the x-axis. This means this will go here. It's flipped over the x-axis, and this portion is flipped over the x-axis, so it will be down here. So this one is negative 3x cubed. All right, so negative exponents. So let's look at f of x equals, let's skip the k. K is 1, I mean. 1 times x to the negative 2. What is the domain of this function, f? Well, I know that a negative exponent, I can transform that into a positive exponent by flipping. So x to the negative 2 is the same as 1 over x with positive 2. So what is the domain of this? Can x be anything? Well, it's a ratio, so I know that the denominator can't be 0. So x squared cannot be 0 means that x can't be 0. So the domain is everything but 0. And how do we write down in interval notation? It's negative infinity to 0, union 0 to infinity. So when I do the graph, I have to keep in mind not to give the value 0. Well, I wouldn't be able to get a value out. So let's see. Let's graph this one first. So let's give some plausible x's. So let's start negative 1. When x is negative 1, negative 1 squared is 1. So negative 1, 1. When x is, let's give a negative 2 as well. So when x is negative 2, I'll have that y is 1 over negative 2 squared, which is 1/4. So when x is negative 2, y is 1/4. Let's say 1/4 is right here. So it will be like this. When x is, let's give a number between negative 1 and 0. So when x is negative 1/2, for example, I would have 1 over negative 1/2 squared. This will give me 1 over 1/4, and 1 over 1/4 is 4. So then that means when x is negative 1/2, so right here, the y value is 4. So I will be right here. Okay, so on this portion, I can connect this, and it looks like that. And then I will do the same for positive values. So now when x is 2, or when x is 1/2 again, I will get that y is 4. When x is 1, I will get that y is 1. When x is 2, I will get that y is 1/4. There you go, I have enough. Did I give enough value to see how the whole graph looks like? Yes, sure. I didn't skip any. I got negative values, and I got values close to 0, but not 0 because 0 is not in the domain, and then all the positive values. So this is the graph for 1 over x squared. Now let's look at one. Let's see, g of x is 2 times x to the negative 3. So this was a negative even exponent. So p is even, and then p is odd. So when p is negative and even and odd, let's see how it looks. So I can rewrite this as 2 over x cubed. And again, the domain of this is everything but 0. And let's give some values. So when x is negative 2, the y is going to be 2 over negative 2 cubed, which is negative 8. So this is negative 1/4. So when x is negative 2, the y is negative 1/4. So negative 1/4 is right here. So it would be right here. When x is negative 1, I will get 2 over negative 1 cubed is negative 1, so negative 2. So when x is negative 1, the y is negative 2. Let's get closer to 0, negative 1/2. Then I'll have that y is 2 over negative 1/2 cubed, and this is 2 over negative 1/8. And this will be negative 16. I'm off the chart. I'm already off the chart at negative 1/2. So at negative 1/2, I would be down, all the way down at negative 16. So really down. So this gives me the idea that when I connect these, so my next point is going to be at negative 16. So it's going to go all the way down like that. And then for this one, it will stay like this. Now, what about closer to 1? So let's say 1/2. When I do 1/2, this is going to be 2 over positive 1/8, so that's 16. So at 1/2, it will be all the way up at 16, somewhere in there. At 1, it will be 2. And then at 2, it will be 1/4. So similarly, for this portion of it, it will look like that. So this is how, these are all the main shapes for the power function graphs. Again, we're not going to use a calculator, so it's important that you have a system in mind. How does a power function look like when the exponent is negative and even? Well, you should quickly sketch the 1 over x squared, because that's the simplest one, and then think that also 1 over x to the 4th or 2 over x to the 6th, all of the power functions that have a even negative exponent are going to have these two, this shape, 2 of them together facing this way. All right, so root functions, if I have f of x equals square root of x, or if I have f of x equals cube root of x. Let's see how these look. So you are familiar with this one, more familiar with this one. So I have to think about giving some specific x's. First, what is the domain for this? What are the valid inputs I can look at to get my graph? Well, I know that underneath an even root, the quantity has to be greater than or equal to 0. So my first valid input is 0. So when x is 0, y is square root of 0, which is 0. So I have this. When x is 1, y is square root of 1, which is 1. Should I bother doing 2? Can I graph exactly what square root of 2 is? It's 1 point, not really. So I am only interested in looking at some valid inputs that are also nice to calculate, that give me integers out. So what would be the next one? Well, it would be 4, because square root of 4 is 2. So I can easily do, when x is 4, y is 2. What would be the next one that would give me a nice? Well, I can't do square root of 5, square root of 6, square root of 7, square root of 8, square root of 9. So the next one will be 9. But I don't have it in here. So this gives me enough points to draw my graph for square root of x. All right, what about cube root of x? What is the domain for this one? So this is the domain, 0 to infinity. What is the domain for this? Well, it's all real numbers, because I can have a negative number underneath the cube root. Why is that? Because let's think about it. What is cube root of negative 8? What is this equal to? Can I even do that? Okay, so I'm thinking, is there a number that multiplied together by itself 3 times would give me negative 8? Well, yes, because negative 2 cubed means negative 2 times negative 2 times negative 2 Because we're multiplying a negative 3 times, we're going to get a negative number out. It's negative 8. So this is why we can have negatives underneath odd roots. So that is negative 8. So the domain is all real numbers. So let's graph this. So when x is 0, it can be 0, the y is 0. When x is 1, cube root of 1 is 1. And I can also do negative 1, so cube root of negative 1 is negative 1. And now, what would be the next best thing to graph? Well, it would have to be a perfect cube. So we saw that negative 8 is a perfect cube because the cube root of negative 8 equals negative 2. So I don't have 8 in here, but let's just say 6, 7, 8. So if I pick when x is 8, cube root of 8 equals 2, because 2 to the third equals 8. So 2, it will be in here. And similar for negative 8, let's say it will be here. So now I can see that when I draw this, I can just draw a line, because that's not where the next value goes. It goes in here. So it could be like this. So this is cube root. So the main thing to take from here is that I can have negatives underneath the cube root.